Hello everyone. I hope that you are doing fine. And yeah, I know that it's not easy to live in this time of quarantine, but I hope that everything is going well for you. So I would like to welcome you to the second part of the course of software engineering. This part will be focused on software development and machine learning. So we will review how you can manage to develop a project that is using machine learning. Just as a small note, we will not we will not review how you can use machine learning to do some software development, but really we will focus on how you can develop a software that is based on machine learning, that is using machine learning for some task. So just let me introduce myself. I am Martin Gubry. I'm a PhD student at SNT in the Serval group. I work on machine learning security and reliability. And my main focus for now is to work on adversarial examples, which is a type of attacks that you can do against a machine learning model. So I did a master in statistics and econometrics in 2014, and a specialized master in data science the following year. So I really come from a more statistical background and from statistics. So I hope that I will be able to provide you some insights that you can gain from the statistical part of machine learning. And yeah, I hope that it will be useful for you. Also, I was a freelance data scientist during 3 years. So I hope that I will be able to provide you also some insights from the industry. I was also a fellow in an NGO. And yeah, so my goal here in this class will be able to provide you some theoretical insight from statistics and also some practical advice and practical tips that you can apply in the industry that will be useful for you when you will conduct some practical engineering inside in the industry. So I really hope that I will be able to relate the two theory and practicability, because it both can be yeah, useful to conduct a machine learning project. So my session will be divided in two main parts. First, we will review some basics in machine learning. What's the definition of it? What type of task you can automate in machine learning? A short introduction to the theoretical part. Some very short recall of statistics. And then we will go into more deeper into the machine learning engineering, and we will overview the life cycle of a machine learning project and go into more detail about the phase of model design of this life cycle, which is the first phase. Okay, so let's review some basic definitions of machine learning. So we start with some definition, because sometimes people are quite confused and about the terms and about what it means. So let's try to clarify this. So AI is a very general scope. It includes a lot of algorithm, a lot of solution. It's very general. So Wikipedia defined it as any device that perceive its environment and take actions that maximize its chance of successfully achieving its goal. So you can see that it's indeed very general. It can include a lot of things. Just doing some classical software development, some if-else statements, a bunch of if-else statements can be part of artificial intelligence. So machine learning is a subfield of artificial intelligence. And here you also perform a specific task, but you don't to automate it, you don't explicitly program it. You are using some data instead to learn how to automate a specific task. So yeah, a famous quotation from Arthur Samuel is, how can computers learn to solve problems without being explicitly programmed? So it's a very general question, but I hope that you will be able to gain some insights from this course on how you can deal with that. So let's just remember that AI is very general and machine learning is a subfield where you use data to solve a task. And yeah, so artificial intelligence is also composed of traditional software engineering, but the fact that machine learning, some parts are not being explicitly programmed for, come with some challenge and some problems that that arise from in software engineering. So we will review that in the course, but you will see that it's not easy. But generally, people use artificial intelligence and machine learning without really differentiating the two. And it's quite important to know what is the difference and where you are inside this big scope. Okay, so machine learning can be divided into generally two parts: what we call classical machine learning, or also shallow machine learning sometimes, and representation learning. So in classical machine learning, you have an engineer, so hopefully you, when you will graduate, who define features from raw data. So you have raw data, the engineer defines some features, and the features is really the way that you represent your raw data to your model. So your model will not have access to the raw data, but will have access to this fixed representation, that you give it to him. So yeah, it's called shallow machine learning sometimes, and in opposition with what we call representation learning. Representation learning, in this case, you learn both the features from the raw data, so the way you will represent your raw data to the machine to the model, and the way on how to use these features to perform a task. So yeah, in representation learning, basically your machine learning model will have more work because he will have to learn what are the useful features it can use, and then how to know how he can use it. So it basically replaces manual feature engineering, so a lot of manual work, but it comes at a cost, and we will see that later. But yeah, and deep learning, you may have heard of deep learning. It's very popular right now. There is a lot of new things, and it's a very dynamic field. And deep learning is basically representation learning with neural network, which is a type of model. So it's basically you learn both the representation and how to use this representation with a neural network. The neural network have to do both. Okay, so I hope that it's a bit clearer. So you can see that artificial intelligence is a very general scope. It includes machine learning, and machine learning can be divided into two parts: classical machine learning and representation learning. Okay, so a bit of vocabulary so that we can all be on the same page. So an example in machine learning is an object or a person. It's basically what you want to give to your model. It's the abstract type of things, the things that you want to give to your model. So usually it's represented as a row of a dataset, and yeah, and a features in machine learning is an input variable. It's represented usually as a column, as a one-dimensional array, and it's one characteristic of your example. So it can be, we will see some example later, but basically it's one characteristic. It's one characteristic of examples. A label, it's really the output variable. It's your what you can call an answer or a result. Is the thing that you want to produce, and usually it's represented as a column of a dataset, and a dataset is a set of examples, and you can imagine that it's usually represented as a matrix, or as in mathematics, or a two-dimensional array. So a dataset, in dataset you have examples that are following each other as rows, and in columns you have different features, a lot of features. And in columns you can also have a label. In the Google developers website, you have a glossary. I put a link here. It can be really useful if you have some doubt about some specific terms, some specific vocabulary. So if you want to keep this link in mind, I think it can be useful for you to refer to this when you need it. Okay, so let's review the type of task that you can handle with machine learning. Machine learning, one part of machine learning is called unsupervised, and the other part is called supervised. Let's see supervised learning first. So in supervised learning, you have two types. For each example, you have two types of data. You have input, which is features, and you have output, which is label. So the features are usually noted as X with an X, a big X, and label with a small Y. And so the important part here is that for each example, so for each thing that you want to analyze, you have to have features, a set of features, and a label. The important part here is that you need that for each example. You cannot just have a bunch of examples that you have in your database and a bunch of labels that are not related to your features. It's really important that for each example you have both, because if you just have a bunch of labels and a bunch of features that you cannot relate, you cannot make a join between the two, it will not be possible for you to do some supervised learning. So what's the goal of supervised learning? Well, the goal is to learn a mapping function that where you input some X, some features, and you output a label, a Y. Here, when I talk about mapping function, it's in the mathematical sense. It's not necessarily a function as in software development, in software engineering. So you input X and you want a Y and hopefully you want the best Y as possible. Okay, so I just put the focus on the learning part here. The goal is really to learn such a function. You don't have, this function is not known in advance without data. So in traditional software development, you may come up with a mapping function like that, but it will be deterministic and you will know it before putting some data into it. Here, you want to learn it to be able to use it. You cannot use it without data. Okay, so let's see some example of supervised learning. One typical example is spam filtering. So here in spam filtering, an example is really an email. You want to input an email to your system that will output 1 if it's spam and 0 if it's a ham, if it's not a spam. So the label here is 1 or 0. And the features, you can have a lot of different features. The features are never really unique. You can come up with very different features, and there is no unique answer on what type of feature you should use. There is really, if you minorly define it, there is really a lot of possibility to define it. Obviously, not all features are good, but yeah, it's you have a lot of possibilities. So here, for example, an email can be characterized as the frequency of some characters or some words inside the body of the email. So, for example, you can look at how much dollar sign you have, or how much Viagra word you have inside an email, and then you feed that into a machine learning model, and it will output you a label if it's a spam or if it's not a spam. So here, Spambase is an example of such a data set. You can take a look at it if you want, if you are curious. So this type of task is called binary classification. So what is classification? Classification is a type of supervised learning when you label a variable. Your label it can take only some finite numbers of value. So here it can only be 1 or 0. Your label can only take the value 1 or take the value 0. So it's called binary because it can take only 2 values. So yeah, let's go on into the next example. So the next, another type of classical type of supervised learning is called optical character recognition, or OCR. You may know it. And a very classical data set in machine learning is called MNIST. It's basically the hello world of machine learning. And yeah, you will see if you do some machine learning, you will see MNIST a lot. So what is an example here? An example is a grayscale image of a digit. So you have in MNIST, you have a 28 by 28 image that is composed of grayscale pixel, and the total image represents a digit between 0 and 9. So here your features are your pixel values. So you take the pixel values that yeah, that is a number, and it's represented by default as a matrix, but you flatten it. You put it as a vector, and you put each row after the other. So then you have a one-dimensional array that you fed to your machine learning model. And what is the output that you want? What is your label? It's the value of the digits. It's between 0 and 9. So it's also classification, because your label can only take a finite set of value, a finite number of values, 0, 1, 2, 3 until 9. But this time it's called multi-class classification, because you have more than 2 classes that it can take. Recall that before we had binary classification, now we have multi-class classification. Okay, so let's see another example. So another example of supervised learning is house price prediction. So a classical example of dataset for that is the Boston housing dataset. So in this dataset, an example is a house. So a house, you can have different characteristics of it, and you use it as features. So you can have the average number of rooms, you can have the age of the house, the crime rate of the town, etc. So you can have a lot of features there. You can have the number of bathroom, also the surface in meters squared. You can have a lot of features. Okay. So the features is a characteristic of your example of the house. And what's the label in this case? Well, the label is just the price of the house. You want to predict the price of the house. So it can be used in a lot of cases, but it's basically practical to know what to predict the price of the house. And here we face a regression task. It's a regression task because the label is a continuous variable. So here we are the label, the price can take any positive value basically. So we don't have a finite set of values like in classification. We have a continuous variable. You can take any values basically of the price. So we call that regression. Sorry. Okay, so we saw that there is in supervised learning, we have some, for each example, we have features and we have a label. But you also have unsupervised learning in machine learning, and in unsupervised learning, you have no label. You still have some features for each example, but you cannot, you don't have a specific label to predict. So here, in that case, you cannot learn a mapping between features and label because there is no label. But here the goal is to discover patterns in the data, so in the features. You want to discover patterns. Okay, so what are the examples of unsupervised? So one type of task, one type of application is called market segmentation. So in market segmentation, an example is a client. So you have a company that is producing or selling some stuff, and they want to know who are the clients and that they have. So here they can compute a lot of features that they have, for example, the history of what each client bought in their company. So they can compute some feature like, has the client bought recently, like less than a month ago? Did he fill the complaint to the support team? Did he had bought a specific type of products, etc. So you can compute a lot of features. Okay, and here note that you don't have a specific label. You just have a bunch of clients. Obviously, it depends on what you want to do, but here the goal is to discover group of similar clients. And you can say that, yeah, but I can compute I can set a label that if a guy bought how many euros the guy bought, for example, or things like that. And yeah, obviously it can be useful in some task to predict how much a client will bought in the next months, for example. But it's not necessarily what you want to do here. The markets in the market segmentation task, you just have a lot of clients and you want to create group of clients. And so you can use that, for example, to make the differentiated communication or differentiated offers, because maybe some type of clients will be interested into buying some stuff, some other type of client will be interested into buying some other things. And yeah, so it can be beneficial for the company to make differentiated communication. So this is called clustering. In clustering, you don't have label. So in the example, in the figure, you have two features. You have x1 and x2 in the features in vertical and horizontal axis. And you see that on the unclustered data on the left, you just have blue points, blue dots. You don't know what are the clients, what are the group of clients. And what you want to have in the end is to have some cluster data, so the figure on the right. And in this figure, you have some three groups, and the red, the blue, and the green. And it can be useful then to analyze what are the characteristics of the red group, what are the characteristics of the blue group, and the green one. So therefore, if you can create some groups like this, you can analyze it and know that the red clients have such a characteristic, are more interested into this type of products. The blue one are more interested into this type of products, and the green one, for example, are, I don't know, clients that are not active anymore, that bought you one time and then they never bought products again. Okay, so just specification here. In clustering, the goal is to create the groups that are most similar to inside, like the client inside each group have to be the most similar possible. And also another objective is that the clients inside the group are the most dissimilar possible to client inside other group. So basically you want the right points to be closer as possible, but also to be as far as possible from the green and the blue one. Okay, so this is clustering. You have some features and you want to create some group of examples that are similar to each other. But another type of unsupervised learning is anomaly detection. So in anomaly detection, one type of anomaly detection is intrusion detection systems. So what you want to do is that you have a system and you want to detect when there is an intrusion that will provoke some anomalous behavior. So here in the graphic, you have it's real data that is taken from Twitter, and basically Twitter here have, for example, the number of requests, and they want to know when there is an intrusion, or maybe when there is a DDoS attack, and to know when to intervene and to fix it. So to do some monitoring. So here, note that we don't have label. The blue dots inside the figure are the result of the machine learning task. So you don't know a priori the blue dot. It's what you want to discover. So here, when you want to have a thing, you just in the beginning you just have feature, which is, for example, the number of requests in time, and you want to detect when there is some peak inside the thing. So you can say that, yeah, but it doesn't seem that useful. I can just draw a horizontal line, set a threshold, and say that when my number of requests is higher than a specific threshold, I will say that it's anomalous. And yeah, it can work if your system is stable, if you always have the same number of requests or things like that. But if you, for example, if your system is slowly growing, like you have more and more users in Twitter, for example, well, if you set a threshold that is fixed, you don't. It will work at some time, but when it grows up, it will be normal to be up to this threshold, and your system will throw a lot of alarms that doesn't correspond to any type of attacks. So yeah, you can see that it can be beneficial to learn when to detect anomaly, for example. Okay, so anomaly detection is another part of unsupervised learning. Sorry. Okay, so just recall that we have seen that you have supervised learning. In supervised learning, you have some features and some label, and you want to create a mapping between the two. And in unsupervised learning, you just have some features and you want to discover a pattern in the data.